Welcome everyone to the What Happens When channel, where everyday questions are answered. Before we get into it, why don't you hit the subscribe, like, and smash the notification bell? Okay, let's do this. Imagine a world where everything we take for granted suddenly changes in the blink of an eye. The Earth, our steadfast cosmic dance partner, abruptly stops its eternal spin. This isn't science fiction. It's a fascinating thought experiment backed by real scientific data that reveals just how precarious our existence on this rotating sphere truly is. The Earth's rotation has been a constant companion since our planet's formation, spinning at roughly 1,037 miles per hour at the equator. This motion isn't just a cosmic curiosity. It's fundamental to life as we know it. When we consider the possibility of this rotation coming to a halt, we're confronting one of the most catastrophic scenarios imaginable, one that would reshape our world in ways both dramatic and subtle. The immediate effects would be nothing short of apocalyptic. As the Earth's rotation slows to a stop, the momentum of everything on its surface would continue at the previous rotational speed. Ocean waters, no longer held in place by the centrifugal force of rotation, would surge across continents at speeds exceeding 1,000 miles per hour. These mega-tsunamis would dwarf anything in recorded history, carrying enough energy to level mountain ranges and reshape coastlines. The atmosphere, too, would maintain its momentum. Winds would tear across the surface at the same speed as the Earth's former rotation, creating supersonic storms that would strip away topsoil, level forests, and make the surface virtually uninhabitable. Buildings, infrastructure, and any exposed surface would face forces far beyond their design tolerances. According to NASA's atmospheric models, these winds would persist for months before gradually settling into new, alien patterns. But the challenges wouldn't end there. The Earth's magnetic field, generated by our planet's rotating liquid core, would begin to weaken. This magnetic field serves as our shield against harmful solar radiation. Its deterioration would expose us to increased levels of cosmic rays and solar wind, potentially leading to widespread electrical disruptions and increased cancer rates among surviving populations. Gravity itself would seem to change, though not in the way many might expect. The Earth's rotation creates a slight centrifugal effect that makes objects appear about 0.3% lighter at the equator than at the poles. When rotation stops, this effect would disappear, leading to a subtle but noticeable increase in apparent gravity near the equator. The Earth would also begin to reshape itself, becoming more perfectly spherical as the equatorial bulge, maintained by rotational forces, gradually subsides. The impact on human survival would be severe. According to climate models, the cessation of rotation would create two extreme climate zones. The sun-facing side would experience perpetual, scorching daylight, while the dark side would plunge into endless night. Temperatures would soar above 150 degrees on the day side and plummet below 150 degrees in the eternal night, creating an almost impossible environment for life as we know it. The challenge of maintaining technological civilization under these conditions would be unprecedented. Engineers and innovators would need to develop entirely new approaches to infrastructure, agriculture, and human habitation. Underground settlements might become necessary, protected from the extreme surface conditions. Advanced climate control systems would be essential for survival, requiring unprecedented energy resources and technological innovation. Communication systems would need complete redesign. Our current satellite networks, designed for a rotating Earth, would become useless in their current configurations. New systems would need to account for the static position of ground stations and the altered distribution of human populations forced to migrate to more habitable zones. The question of how to organize society in such conditions raises profound ethical dilemmas. The need for transparent communication about resources and dangers would conflict with the imperative to prevent panic and maintain order. Privacy concerns would arise as surviving governments attempt to monitor and control population movements and resource distribution. Innovative solutions would be crucial for survival. Engineers propose concepts for massive atmospheric processors to regulate temperature extremes, while others suggest the possibility of artificial rotation systems for smaller habitats. The challenge would drive unprecedented cooperation between nations and scientific institutions, assuming they survive the initial catastrophe. The cessation of Earth's rotation would also have profound psychological impacts on surviving populations. The loss of day-night cycles would disrupt circadian rhythms, affecting sleep patterns, hormone production, and mental health. Adaptive lighting systems would become essential for maintaining any semblance of normal human biological functions. Current research in chronobiology suggests that humans can adapt to alternative day-night cycles, but The complete absence of natural cycles would present unprecedented challenges. Medical professionals would need to develop new treatments for sleep disorders, depression, and other psychological conditions exacerbated by the environmental changes. The scenario raises fascinating questions about human adaptability and resilience. Throughout history, our species has demonstrated remarkable ability to survive in extreme environments, from the Arctic to the Sahara. However, the stopping of Earth's rotation would create conditions far beyond anything we've evolved to handle. The role of technology in survival would become more critical than ever. Artificial intelligence systems might become essential for managing resource distribution and maintaining the complex systems necessary for survival. This increased reliance on technology would create new vulnerabilities and dependencies, requiring careful balance between efficiency and resilience. The expertise required to maintain crucial infrastructure would become one of humanity's most valuable resources. Knowledge preservation and transmission would be paramount, as the skills needed to operate and repair survival systems couldn't be lost. This would likely lead to new forms of education and apprenticeship, focused intensively on practical engineering and survival skills. Transportation between surviving communities would present unique challenges. Traditional aircraft would need complete redesign to account for the new atmospheric conditions. Ground transportation might become more prevalent, though the extreme temperature differentials would require new materials and engineering solutions. Water management would become a critical concern. With the oceans redistributed and normal precipitation patterns destroyed, access to fresh water would require new approaches. Advanced filtration and recycling systems would be essential, along with methods for harvesting atmospheric moisture in habitable zones. Food production would need to shift entirely to controlled environments. Traditional agriculture would be impossible in both the perpetual day and night zones. Vertical farming, hydroponics, and other intensive growing methods would become the only viable options for sustaining human populations. The scenario also presents opportunities for scientific advancement. The unique conditions would allow for experiments and observations impossible under normal circumstances. Our understanding of geophysics, climatology, and human adaptation would advance rapidly, driven by immediate survival needs. The stopping of Earth's rotation would force us to confront fundamental questions about our place in the cosmos. The delicate balance that makes our planet habitable would become starkly apparent, perhaps changing our perspective on environmental stewardship and technological development. Long-term survival would depend on our ability to create sustainable artificial environments while developing potential solutions for restarting planetary rotation, a challenge that currently exists only in theoretical physics. The knowledge gained from adapting to these extreme conditions might prove valuable for future space colonization efforts. This scenario, while catastrophic, illuminates the remarkable systems that make Earth habitable and the ingenuity we would need to survive their disruption. It reminds us of our dependence on planetary processes we often take for granted and challenges us to consider our readiness for extreme environmental changes. As we contemplate this thought experiment, we gain new appreciation for the complex dance of forces that makes life possible on our spinning world. Perhaps most importantly, it highlights the critical importance of scientific understanding and technological innovation in facing future challenges, whether they come from stopping rotation or other global-scale disasters. In the end, the scenario of Earth's rotation stopping serves as a powerful lens through which to examine our relationship with our planet, our technology, and each other. It underscores the importance of maintaining and advancing our scientific knowledge while preparing for unprecedented challenges that may lie ahead in our species' journey through space and time. Thanks for watching.